Hey guys, in this video, I'm going to show you how to graph an exponential function. So when you're given an exponential function, it's important to recognize several different things before you actually start graphing. The first of which is understanding whether or not the function is growing or decaying. And the way that you decide that is by looking at the number inside the parentheses. If that number is bigger than 1, your function is growing. If it's less than 1, it's decaying. So in this case, since this number is bigger than 1, that means that I have exponential growth. Okay? Then I know this because the number in the parentheses is greater than 1. The next question it wants us to figure out is what is the percent of increase or decrease? Well, if you think back to last week, if it's a growth, you need to take the number, subtract 1, and change it to a percent. So 1.3 minus 1 is 0.3, which as a percent is 30%. So this is an increase of 30%. All right, now using the equation again, what would our start value be? Well, the starting value is always the number in front of the parentheses. So in this case, it's 10. That also means that the y-intercept is 10. It's the same thing. All right, how many points are needed to make an accurate graph? Well, you always want to plot your y-intercept, and you want to plot a minimum of 1 point to the left of the origin, and as many points on the right as needed to see the increase or decrease. Okay, so basically, try and get as many points as you can. All right, so let's do that. The table is already given to us. All we got to do is fill it in. So we're going to start at -2, just like we used to. Then -1, 0, 1, 2, 3, 4, 5, and 6. Okay? So let's plug in all of our numbers here. So I have 10 times 1.3 to the -2nd power is 5.9. Now let's do to the negative first. (7.7). Okay, now let's do the 0 power. That's 10, which is what we expected. That's our y-intercept. And 13. 16.9. 21.97. Almost 22. 28.56. 37.13 and 48.27. All right, and then we're going to graph that. So you're going to have to estimate a lot, and that's okay. So -2, 5.9. So this is just under 6. So -2, and if you notice, each line, or every other line rather, is going up by 10s. That means each individual line is going up by 5. So for this one, I want to be just above 5. Okay. Then I have -1, 7.7, so it's slightly higher. (0, 10), 113. So as you can see, we're not yet able to see the curve, so we're going to have to keep going. 2, 16.9. So here's 15, so 16 is probably somewhere in there. 3, 21.97, which is almost 22. So here's 20, and that's 25, so right about there. 4, 28.56 is almost to 30, not quite there. 5, 37.13. So here's 30, 35, and slightly higher than that. And then 6, 48.27. So here, that's almost to 50. So now we can kind of see the curve here. So I'm okay with just drawing my graph. It's going to keep going up like that and slowly going down that way. All right, so now let's take a look at a decay example. Same type of problem, it's just decay. Sorry, wrong page. All right, so we have this equation here, y equals 40 times 0.8 to the x. I know that this is decay because this number is less than 1. Okay, so this is decay because the number in the parentheses is less than 1. Okay, to find the percent increase, I need to take this number and subtract it from 1. So 1 minus 0.8, and then change that to a percent, and I get 20%. My starting value is 40, which is also going to be my y-intercept. Remember, those are the same thing. All right, and then let's fill out the chart just like we did on the last one. Okay, now I'm still going to start with -2, because that's as far left as this graph even goes. -1, 0, 1, 2, 3, 4, 5, and 6. Okay? All right, so let's plug all that information in. Okay, and I would keep going here. I already have the numbers written down, so I'm going to go ahead and write them. So it's 40, then you should get 32, 25.6, 20.48, 16.38, 13.11, and 10.49. And you can test that by doing the same thing in your calculator. Just plug each of the x's in for x. All right, now let's take a look at the graph. -2 is at 62.5. So -2, here's 60, and that's 65. So we're somewhere in between. Okay, -1 goes up to 50. 0 is at 40. Still can't see that curve yet. 1 is at 32, which is just above 30. 2 is at 25.6. It's just slightly above 25. 3 is at 20.48, just above 20. 4 is at 16.38, somewhere about there. Actually, it might be a little lower, because here's 15. 5 is at 13.11, just above here. And 6 is 10.49, which is right above there. So it's starting to slow down there. So here's my curve. It's going to keep getting lower and lower, and it's going to come very close to the x-axis, but never quite touch it. Okay? And that's it. That's how you graph exponential functions.